Hello everyone, my name is Denis Ilyash and this is my CMPT 461 video. Today I'd like to talk about the paper called Sky's Not the Limit, Semantic-Aware Sky Replacement by Tsai et al. 2016. Skies are common backgrounds. However, photos that have skies as a major part may look boring due to the weather conditions or time of the day. This paper is aimed to develop an algorithm that will search the database to find semantically similar images and replace the sky in the original one while inheriting the coloring from the reference image. There were some earlier papers on this topic, but they did not account for the image's semantics. The process described in this paper consists of three major steps: segmentation, search, and semantic-aware replacement. Let's start from segmentation. We would like to precisely define boundaries for the sky region during this step. First, we train a fully convolutional neural network (FCN) on the LM-SAN dataset. There are many labels in this dataset, but we don't need all of them for our purposes. 10 of the most significant ones are manually selected. Others are merged into the foreground object label. This model can effectively localize the sky in the image and distinguish the true sky from confusing regions such as sky reflections in the water. We modify the output to be the probability map for each pixel, which contains the likelihood of pixel belonging to a particular label. However, since the resolution of FCN's output is low, we train the online classifier model to get more precision near the true object's boundaries. This probability map facilitates all steps of our process. Now, let's talk about the second step, search. Earlier approaches have mainly used these descriptors. However, a method like this describes only global scene layout without important semantic information. The newly proposed descriptor captures overall semantic layout of the image and allows some variations during search. The semantic layout descriptor for each image consists of 10 arrays. First, an image is divided into 3 by 3 grids, and probability maps are converted to histograms through an average pooling process for each such sector. 10th array is the same average pooled histogram, but for the whole image now. We also define aspect ratio search restrictions. Since we use semantic information features instead of the traditional appearance information features, we can find images with different appearances, which gives more artistic value to this algorithm. Now let's talk about semantic-aware replacement. After we found a match and replaced sky of our original image with sky from our reference image, we would like to inherit lighting and coloring from the reference image. We do this in the way that the lighting and coloring of a particular label in original image is inherited from this label's lighting and coloring in the reference image. Category-specific transfer functions must be created first for each semantic label. LAB color space is used. Here's an example of image with sky swapped, without any changes in lighting or coloring. The next step is to change luminance. For luminance, we first shift the mean in the original image to match the reference image. Then the difference in color means is calculated. The luminance transfer function defined this way changes the luminance of the original image particular segment more aggressively if the color difference is significant. Here, arrows are pointing to the regions with more obvious changes in lighting. For chrominance, we added the channels of LAB color space by matching the mean and covariance of the original image to our reference image chrominance. The proposed method produces aesthetically pleasant and robust results. Here, you may notice the huge difference between images without and with semantic-aware replacement. However, there are some problems as well. Here, in the circle, is a segment that was never replaced, because it is disconnected from the main sky part. In the rectangle, you may see that the clouds near the mountains may also result in incorrect segmentation. In this image, we try to replace this beautiful sky with plain blue. However, you may notice that the heavy red coloring can't be fully swapped out from the sky. The next problem occurs in foggy images. Here you may notice that even though sky is replaced properly, there is leftover fog that looks unnatural and can be corrected. Here is just part of the mask that was created. so you can verify that segmentation is correct. Thanks for watching, and if you're interested, you can find simplified implementation of this paper in Adobe Photoshop.